Question 3, you've got z is 2 minus I. Find the modulus of z and the argument of z. Now some of you have calculators that will just tell you this stuff, but this would be the square root of 2 squared plus minus 1 squared. Now remember, when we put that in, we're not doing 2 squared plus I squared, because that ends up giving us the wrong answer. It's about the length of the line that it would be. That is the square root of 5, and there's our answer for the modulus. The argument, well, it might be helpful to have a little diagram of this, do you think? Here we've got 2 minus I, so that's where the point 2 minus I would be. That would be its modulus of being root 5. What we're looking for here is the angle it makes with the positive x-axis, the positive real axis. So we need to think about the right angled triangle. That opposite is minus 1. The adjacent side is 2. So if we think about that in terms of our trigonometry stuff, the tangent of the angle is opposite over adjacent. I did this in radians, but I'm not sure that they actually cared in the mark scheme. I can't remember. What did this say? They had it in both. They had degrees and radians. If we do that, it comes up with minus 0.464 radians. That's the argument of Z. 2, 3 figures. Of course, it has to have this minus sign in there, because we have to indicate that it's below that axis. And actually, the place that a number of people went wrong was got the right angle, 21.6 degrees, I think. They got the right angle in there, 26.6, sorry. But they missed out the sign. It's got to be there. The next part, again, we've got loads of marks for something here. Part 2, we've got to show that, given that, AZ plus B Z with a little star thing next to it is 4 minus 8I. And actually the first thing here is for us to recognise what this little star thing above Z means. What does it mean? The complex conjugate. So that means that we've got A times 2 minus I plus B. And there is our first mark straight away, just for recognising that the complex conjugate is 2 plus I. We now need to collect together real and imaginary terms. So we've got 2a plus b, 2a plus 2b as the real part, and then we've got minus a plus b as the imaginary bit, and here we've got 4 minus 8i. And that gives us a really nice simple set of simultaneous equations. If we evaluate the real bits, we get that. If we evaluate the imaginary bits, we get that. Minus 8 plus b would be minus 8. The first equation is probably nicer written as being a plus b equals 2. And then it squares however you want to simplify these now. What can we do? A is b plus 8. If we rearrange that, if we do a substitution there, we've got b plus 8 plus b is 2, so 2b is minus 6, b is negative 3, therefore a equals 5. And it just said find a and b, didn't it? Yeah. So there we go, that's our marks. The key to it, of course, was getting this bit right, and then recognising that it's evaluating real and imaginary parts to get your answer. Magic.